Hi, in the previous videos we have been talking about breadth-first search, what is breadth-first search, and what are the applications. We have been talking about the so-called web crawler, and in this video we are going to implement from scratch a basic web crawler. So I'm going to create a distinct package with the name web crawler, and I'm going to have two classes. First of all, the web crawler, and then the application itself. And in this case, we are not going to create a vertex, because as we have discussed in the previous video, in this case, the vertices are represented by URLs and websites, so http://www.google.com, for example, and basically we can use a string instead of a vertex custom object. So that's why I'm not going to create a vertex. In the web crawler, we are going to have a queue. So it's very important that the basics are going to remain the same. So it's going to remain a basic breadth-first search. So we have to use a queue abstract data type. So a private queue, but instead of storing vertices, in this case, I'm going to have strings. So string. For example, the name will be queue, then I will have a private list of strings. Basically, it is the discovered websites list. So we have to store in a list the discovered websites to be able to track whether we have already visited the given website or not. I'm going to import the java.util.list, and I'm going to import the java.util.queue. Then in the constructor, I'm going to instantiate the queue. The queue is an abstract data type, and we can implement it with the help of linked lists. The linked list implements the queue interface, so basically we can instantiate the queue as a linked list, and I'm going to do so. The this.discovered website is going to be a new array list. Okay. We will have a public void discover method, or discover the web. We will have a root as in the previous videos. This route is going to be a website, a URL, http:// for example bbc.com, from where we are going to start the web crawling. Okay, I'm going to add this queue.add root, and we add this root to the discovered website list. So add the root. So the queue is going to contain the root, and the discovered website list is going to contain the root. Anyways, the structure of the breadth-first search is going to remain the same. We have a queue, and while the queue is not empty, we are going to iterate with the help of this while loop. We will have the website, basically, the for example, this.queue.remove. We are going to remove an item from the queue. It's going to be a string, and this string is basically going to be a URL, a website. Okay, then we will have a raw HTML, CSS, and JavaScript related text, and basically we have to find the URLs in this text with the help of regular expression. So I'm going to have the string, for example, raw HTML. I'm going to read the URL. I'm going to create this method, which is going to take a URL and going to download the HTML content of that URL. So of course, for this method, we definitely need internet connection. Okay. I'm going to have a string raw HTML. I'm going to have a try-catch block. In the catch, I'm going to catch all the exceptions. Okay, it's not a good programming practice, but whatsoever. Print track trace. Okay. And basically I'm going to have a URL with a new URL. With the help of this, we are able to connect the URL java.net. Okay. Then I'm going to have a buffered reader because we would like to read the data from the web. For example, in is equal to a new buffered reader with a new input stream reader, and basically we just have to open the URL open stream. Okay. And we are going to read the raw HTML on a line-by-line basis. So just to be clear, we are able to take a look at the source code. Let's take a look at the source code behind the website. And what we are going to do, we are going to read the data from here on a line-by-line basis. And we are going to pose the question on every iteration that, okay, is there any URLs in this raw HTML? What is a URL? A URL basically is everything that's similar to this one. It starts with http://, it has several dots and so on. And basically we are going to do it with the help of this read URL method. So we are going to open the URL and we are able to read it on a line-by-line basis. String the input line. It would be better to use a string reader, but anyways, just for demonstration purposes, it's going to be okay. So while the input line is equal to the in.readLine is not equal to null, which means that we have some data to read. Then we are going to append this line to the raw HTML. So the input line we have read here is going to be appended to the raw HTML. Basically we have to close the buffered reader, so close, and in the end we are going to return with the raw HTML. Okay, so let's take a look at it again. We have the rows HTML, we have the URL, we connect to the string v. What is this v? It's going to be the URL of a website, http://www.udemy.com, for example. Then we have a buffered reader with a nested input stream reader with the URL .openstream. It is a beautiful decorator pattern, by the way, whatever. Then we have the input line, and while the input line, which is the in.readLine, is not equal to null, it means that we are not at the end of the HTML document. Then we read the input line by line and we append it to the raw HTML. We close the buffered reader and we return with the raw HTML. Okay, so we have the raw HTML, and after that we are going to have a regular expression to be able to get the URLs out of this raw HTML. So we are looking for something like the http:// and basically w plus / point star / w plus. Okay, basically it means that we are looking for anything that's going to be approximately a URL. So we will have an http://, we will have www, we can have several dots and so on. So this is regular expression is going to make sure that we are going to find the URLs in the raw HTML, because this is exactly what we are looking for. And we just have to use this pattern, and pattern.compile, we have to compile the regular expression, and then we have to create a matcher which is equal to the pattern. In this phase it's going to find the concrete matches. So it's going to find the URLs in the row HTML. We have to specify the row HTML and we have to import the matcher. While the matcher find, it means that we have found some URLs. So maybe we have several URLs in a single web page, then we would like to find all of them. And if you hover your mouse on the find, it's going to have a good documentation, attempts to find the next subsequence of the input sequence that matches the pattern. So it's going to find the next URL in the row HTML. And then we are going to have the URL, for example, actual URL is equal to the matcher.group. It's going to return this URL. If you hover your mouse over this group, returns the input sequence matched by the previous match. So it's going to return the URL it has found. Okay, so it's the actual URL. And if the discovered websites list isn't contains this actual URL, it means that we haven't visited this URL, this website so far. So first of all, I'm going to add this actual URL to the discovered websites. Then I'm going to print out that website has been found with URL, plus I'm going to print out the actual URL. And then I'm going to add this actual URL to the queue, as we have seen for the standard breadth-first search. Basically, again, it is a quite compact algorithm. We have a breadth-first search-like structure, but instead of vertices, we have strings, because we are dealing with websites, with URLs. And we have a queue, we add the root website, the root URL. We have a discovered website list. And while this queue is not empty, we first of all, we remove the item from the queue. Then we get the row HTML from the given URL. Then we search for URLs on that given row HTML. And we iterate through all these URLs. And if we haven't visited that website, we are going to visit it. And that's why we add it to the queue. And we track that, okay, we have already visited that website. It's very important in order not to visit a single website over and over again. So that's why we have to check whether we have already visited that website or not. The main method is going to be quite simple. We have the web crawler. Crawler is equal to a new web crawler. Then I'm going to specify a root URL from which we are going to start our web crawling. It's going to be http://www.bbc.com. Then of course we have to call the crawler.discoverWeb starting at the root URL. So let's see whether our web crawler is working fine or not. As you can see, it's quite working fine. It's going to crawl from URL to URL. Of course, there will be some errors because sometimes it's not going to be able to connect the given server. So sometimes it fails to get the HTML. But anyways, it is able to crawl from URL to URL. As you can see, there are several websites, GitHub, there was the Facebook, there was the ogp.ma, American, Hungarian, German, Spanish websites and so on. I think it is quite beautiful to see that how a web crawler with such small code is able to operate and work quite efficiently. So that's all about this web crawler, and basically it's very important to use breadth-first search as a graph traversal algorithm because it's going to traverse the neighbor of the root URL instead of going too far, because we could use the depth first search, but depth first search is going to go as far as possible from the root URL. And with web crawling, we would like to discover the neighborhood, the local environment of the given root URL, so the BBC. So that's why for web crawlers, we usually use breadth first search, and that's why I implement with breadth first search as well. Thanks for watching.